Hello class, today we are going to look at finding area with trigonometry. So we're just going to jump right in here, and we want to find the area of this triangle. So we got a triangle, everybody knows that's 1/2 base times height. So not a big deal, 1/2 base is 12, height is h. What is the height? What are we going to do? We didn't give us the height, gave us an angle, gave us another side. Well, what we're going to do is we're going to take this right here. This is a right triangle. And as you recall, with a right triangle, we can use trigonometry, SOHCAHTOA. So let's see, I'm not going to use the 12 because 12 is not actually part of this little yellow triangle that I'm looking at, this right triangle that I want. But the 5 is. So I can use the 5 and I can use this 38 degrees. So if I do it like that, I've got the 38 degrees, the 5 of the right triangle, that's the hypotenuse, and I'm looking for my height, which is the opposite side from the 38. So opposite hypotenuse, that is sine right there. So what we have is sine of 38 degrees is equal to opposite h over hypotenuse 5. Okay, we want to get h by itself, so we multiply both sides by 5. We have that h is 5 sine 38 degrees. All right, and I could put that in the calculator right now, but I'd rather not because I'm going to round it off. It's better if you just take this 5 sine 38 and plug it into your formula like that. So you have area is 1/2 your base, 12, times your height, which is 5 times the sine of 38 degrees. So let's get the calculator up here. And now we're just going to type that in. So we have 1/2 times 12 times 5 times the sine of 38 degrees. And we get 18.4698, blah, blah, blah. Okay, so we're just going to round that off. And our answer is approximately 18.47. Right. So we have a new formula here that can be used if we don't have the height. We can use trigonometry to find the height. And this can be used even if it is an obtuse triangle like this. We have our base, and then we have an angle, and then this other side right there. So even if it's something like this, we can still use it because we've got the right triangle over here. So we have this right triangle, right, which still works. So what we have is the area is equal to 1/2 AB times the sine of angle C. So 1/2 of this side times that side times this angle in the middle. It even works like this. 1/2 CA times sine of B. It's still this side times this side, sine of that side. Notice in every case, what we have is side angle side. You're given a side, you're given another side, you're given the angle in between. A side, the other side, angle in between the two sides. Side 1, side 2, angle in between the two sides. Have to have side angle side for this to work. All right. So let's take a look at this, just an example. Real quick, I want you to pause the video and find the area of this triangle. Okay, so you pause the video, you're back. Let's take a look. We've got a formula right over here somewhere. There it is. We do have side angle side, right? Sides, angle in between. So we have a formula. Area is equal to 1/2 AB sine C. So 1/2 the two sides times the sine of the angle. Okay, so let's just plug this in. And there it is. So we have 1/2 side 1 times side 2 times the sine of the angle, and we'll just put that in the calculator. Let's put that over so you can see what I'm doing here. So 1/2 times 12 times 37 sine of 42. Always do make sure you are in degrees, not radians. And enter, we get 148.546, so 0.55. And this is inches, so square inches. Right? So that's not too bad, right? Pretty easy, just plug it into the formula, hit enter, no big deal. All right, let's take a look at this. We want to find the area of the parallelogram. Well, parallelogram, the area of that is base times height, but again, I don't have the height, do I? Don't have the height. However, we can do this because, if you'll remember, a parallelogram is really nothing more than two triangles. So, a parallelogram is two triangles, and the two triangles are congruent to each other. We know that because the opposite sides are congruent. DB is congruent to DB, so we've got side congruence. So, what this means is the area of the parallelogram is equal to twice the area of this yellow triangle, right? Because it's just two triangles. So let's get our formula for that. 2 times 1/2 AB sine C, right? But you notice I have 2 times 1/2. Well, 2 times half is just 1. It's kind of cancels out, it goes away. So really, the area of my parallelogram is just AB sine C. Now, one thing's very important. I still have to have side angle side. So I have a side, I have an angle, I need the other side right here, which I don't have, but it's a parallelogram. Opposite sides are congruent to each other. So if this is 24 meters, this one's also 24 meters. And now I have A, B, and side angle C. And I can just take it, plug it into this formula right here, and I'll just move it over there. And we have 43 times 24 times the sine of 134 degrees. So we open a calculator and we have 43 times 24 sine of 134. And we have 742.358. So we'll round that off, that'll be 36. All right. And there it is. 742.36 meters squared, approximately. All of these are going to be rounded because we're using trigonometry, so all of these are going to be rounded off. All right, so let's take a look at something else. Find the area of the regular pentagon. Now, this is going to be a bit different. Okay, so what we're going to do here, we don't have a formula for regular pentagon, but we do have formulas for triangles. And instead of cutting it across into making this just 3 triangles, which would be easy enough to do, doing that's going to be hard to find angles and things like that. So what we're going to do is divide it up like this. Notice this is a regular pentagon, so that means that all of the sides are the same, all of the angles are the same, so all 5 of these triangles are the same. So what I can do with my formula here is the area of the polygon is going to be n times the area of the triangles. Well, n is how many triangles do we have, right? I've got 5 triangles, so in this case, n is 5. And we want the area of a triangle, which we said was 1/2 AB sine C. And I'm just going to deal with one triangle, just this triangle right here. All right, because all of them are the same, so if I find one of them, I find them all. Now, there are a couple of definitions I do want to get into real quickly, and that is radius. Yes, this is not a circle, it has a radius. If you have a regular polygon, the radius is the distance from the center to a vertex. Because I could draw a circle around this polygon, and the vertex there is where the circle would touch the polygon, so this would be the radius of the circle as well. All right. Now there is another term we want to use. Going to talk about this a little bit later. This is the apothem, and that is a line, a segment from the center of the polygon to the midpoint of a side. Any side, doesn't matter. It's a regular polygon. It's all the same. All right. And this apothem here, this is the height of the triangle that I'm going to be looking at. All right. So I'm looking at this orange triangle. I'm going to try and fill in this right here. So n, easy enough. It's a pentagon. It's got 5 sides. Times 1/2 times a. Well, a, for this orange triangle down here, a, well, that's just the side of the polygon, right? The side of my pentagon, that's 32 inches. So I know a. That's easy enough. B, I don't know B. I'm going to have to work it out. So let's just get what I know right now. I know n is 5 times 1/2 times 32. We've got to figure out what B is. And I've also got to figure out what C is. And actually, in order to find B, I'm going to need C first. I'm going to have to do some trigonometry stuff. So how am I going to find this angle? Well, it's a regular pentagon. That means all of the angles are the same. It also means that the radius here is going to bisect this angle. So I just need to find one of these angles. We'll just go with that one right there. And if I find this angle, then I can just cut it in half, and that'll give me angle C, because all of these angles are the same. Now, the easiest way to find this angle, actually, is to find that angle. All right, this is an exterior angle. If you remember, all of the exterior angles together add up to 360 degrees. It's a regular pentagon. All of them are the same. So I can just 360 divided by 5. And 360 divided by 5 is 72. So this is 72 degrees, and these two angles together are a linear pair, which means they're supplementary. They add up to 180 degrees, so I can just subtract 180 minus 72 gives me 108. And I only want half of this. I just want this one here, angle C, just half of that angle. So 108 divided by 2 is 54. So angle C is 54 degrees. Now I'm going to use trigonometry to find out what B is, because that's what I need. I got angle C, and I need side B right there. Now trigonometry is just going to work this SOHCAHTOA, right? Only going to work with right triangles. So I'm just going to be looking at this half of the orange triangle, which means I don't want A. I don't want the whole side. I just want half of it. Well, the whole side is 32, so 32 divided by 2 is 16. There we go. So I have my angle. I have one side. Let's see, this side is right next to the angle, so that will be adjacent. And I'm looking for B, which is the hypotenuse. So adjacent hypotenuse, that's cosine. So what I have is the cosine of the angle, 54 degrees, is equal to 16 over B. I want to get B by myself, so these two switch places. And I have B equals 16 divided by the cosine of 54. Now, I can stick that into my calculator and get a number for it, but you'll notice 16 divided by the cosine of 54 is a great big, ugly, hideous decimal, and I'd rather not use something that I'm rounding off. So when I go to plug it in my formula for B, I am just going to use that trig ratio, 16 divided by the cosine of 54. And I'll type that all in together when I get my answer. And then I need the sine of C, which I said C is 54 degrees. So there it is, sine of 54 degrees. And I'm going to type this into my calculator. That way I don't have to round stuff off before I'm done. So 5 times 0.5 times 32 times, and I'm going to put this in parentheses, 16 divided by the cosine of 54. There you go. It needs two parentheses there because the first one's for that and the second one is for the division there. And then sine of 54. All right. Equals. And there we go. We have 1,761.7688. So round it off, we'll call it 77. Button, there it is. All right. Okay. Now, I'm going to show you another way to do this. This works, and sometimes you'll do it this way. But just so you can see, another way to get this done, exact same question, but we can take it a different way. Instead of using the formula for a triangle as being 1/2 AB sine C, we're just going to use our old traditional standby of 1/2 BH, 1/2 base times height. All right. So again, I'm looking at this triangle here. I know what n is. N is 5, 1/2. I know the base of my triangle. Base is 32. The question is, what is my height? Why does that say B? So we're going to figure this out. Again, we're going to use trigonometry. But this time, instead of finding this angle down here, which I can do, we saw it, it's all good. I'm mistaken to find this angle right here. All right. So this angle is half of this central angle. And all 5 of these central angles are the same. And so, because it's regular pentagon, so all 5 of these angles together are 360 degrees. I've got 5 of them, so I'll divide by 5 but I only want half of that, so I'm going to divide by another 2. So what that means is my formula, what I'm going to do here is 360 divided by 5 times 2. Well, 5 times 2 is 10, and 360 divided by 10 is 36. So now I've got this angle, 36. Over here, I still have half of the entire side. The whole side is 32. I just want half of it, 16. So let's see here. SOHCAHTOA, I am looking now for H, which is my apothem, right? So my apothem there, let's see, that is right next to the angle I know, so that would be adjacent. The 16 is across from the angle, so that's opposite. So we've got adjacent and opposite, that's tangent. Okay. So what I have is the tangent of my angle, 36, equals opposite 16 times adjacent, divided by the adjacent, which is my apothem. All right? I want to get A by itself, so again, these two switch places, and I have this. Again, this is a hideous, ugly decimal, goes on forever, so I'm not going to use the decimal, I'm just going to use the ratio and type that in. So I have that. All right, so now I have 5, my number of sides, times 1/2, times my base, which is the length of my side there, times H, which is my apothem, which I have this ratio. And that's what I'm going to type into my calculator. So let's see, we have 5 times 1/2 times 32 times, I'm going to put this in parentheses, 16 divided by tangent of 36. And I get, notice, it's the same thing we got above that. So, doesn't matter, you can do it this way, you can do it this way, and your answer is the same either way. Now, taking this, notice, look at this. All right, we're going to take this right here, and I'm going to break it down a little bit, rewrite this formula. So, I have that same formula, but instead of having B and H, looking at the triangle, I'm going to look at the pentagon. So, B, the base of the triangle, that is the side of the pentagon, so I'll put an S there. And the height of the triangle, that is the apothem of the pentagon. So there. And I'm going to rearrange these just a little bit. So now I have this. So it's 1/2 times the number of sides times the length of the side times the apothem. Well, the number of sides times the length of each side, well, that would be the perimeter of the polygon, right? So another way you'll see this formula written is this, 1/2 AP. 1/2 times the apothem, which is the height of the triangle, times the perimeter of the polygon. Right? A lot of times you'll see it written like this. Personally, I find this to be more useful, because very rarely will you be given the perimeter. You'll be given sides and things like that. Right. So, for example, last problem. We want to find the area of this regular octagon. And I'm giving us this formula instead of changing this to perimeter. Just number of sides times the length of each side times the apothem. And notice it did not give me the apothem, did not give me the length of the side. Instead, it gave me a radius. Now, it does tell me it's a regular octagon, so I can get this figured out. Okay, so let's put in what I know. I know 1/2 times 8, because it's an octagon. So first, let's find S, the length of the sides. So to do this, again, we're going to draw those triangles like we had before. So there's the triangle I need. I don't have to draw all of them. I know there's going to be 8 of them because it's got 8 sides. And here's one of them. Again, I am going to do this by finding this angle. Right, so it's a regular octagon. All of the central angles add up to 360. So what I can do is 360 divided by 8 times 2, because I want half of the angle, right? So that is going to be 22.5 degrees. All right, so we've got 22.5 degrees right there. And now I can find this. Let's see here. I am looking for S. All right, S and A. So there we go, S and A. Well, I'm looking at this triangle. I'm looking at the right triangle, so I'm only looking at this side right here. This is not S, is it? No. So we're going to call this X. And S is going to be 2 times X. Whatever X is, S is twice that. Okay, so let's take a look here. I have the hypotenuse of my right triangle, and from this angle, x is opposite. So opposite and hypotenuse, opposite over hypotenuse, that would be sine. So I'm looking for the sine of my angle, 22.5, equals opposite over hypotenuse. I want to get x by itself, so we're going to multiply both sides by 7, and this is x. Now I want s, so I want 2 times this, and so there we go. There's s, and again, I am going to leave it just like this because I don't want this great long decimal that I'm rounding in the middle of solving my problem. Because when you do that, it throws you off. So there we go. I'm just going to plug all of that in for s. Now I need to find a. Well, that's not too bad. A is right there. I've already got my angle, right? And another hypotenuse. So hypotenuse, let's see, the apothem is right there next to my angle, so that would be adjacent. So I have adjacent and hypotenuse, that is cosine. So the cosine of 22.5, cosine of my angle, is equal to adjacent over hypotenuse. We want to get a by itself, so multiply both sides by 7. And apothem is 7 times the cosine of 22.5, so we plug that in for a right there. And then we get out the calculator. Here we go. Turn it back on because it goes in power saver mode, which is stupid because it's on my computer. And I just plug this in, so I have 0.5 times 8 times times 2 times 7 sine 22.5, and then I want times 7 cosine 22.5 equals 138.592, so approximately 138.59 centimeters squared. All right, and there it is. Not the easiest thing in the world. Can be relatively complicated. Lots of little steps. Easy to mess this up. So you've got to be very, very careful on this. Make sure you're doing step by step by step. And if you notice this right here, I know a lot of you are thinking, well, why did we do it this way? This is so much longer than... Notice this is very, very similar to how this one ended up coming out. All right. So you're just going to take whatever it is it gives you, and then use your draw your triangle right here, and use your trigonometry to figure out your S and your A. Okay, depending on what they give you, if they give you a side, if they give you the apothem, if they give you the radius, depending on what they give you, depends on what kind of trig ratios you use. Okay, so just to refresh, area of a triangle, if you don't have the height, but you have side angle side there, is 1/2 AB sine C. You can use that also to find the area of a parallelogram. You just don't have to half it because you can double it anyways, so it just becomes AB sine C. Again, still needs side angle side, like that. Still needs the side angle side. I highly recommend you always draw it out. If it doesn't give it, if it just gives you the words, draw it out so you know where your side, where your angles are. All right? And then for the area of a regular polygon, again, only works for regular polygons, you can do it like that or like this. I would do 1/2 times number of sides times the length of each side times the length of the apothem. 1/2 NSA. All right. Hopefully you found that useful, and I will see you in the next video.